Good day. This is my report for the final laboratory activity for the vending machine implementation. So, in this project, I use Quartus 2 and a Verilog HDL file to simulate how a vending machine works based on the implementation indicated in the instructions. So for the introduction, this Verilog code simulates a vending machine that accepts coins, tracks the total, and dispenses a product when the required amount is met. So this vending machine accepts coins, specifically 5 pesos, 10 pesos, and 20 pesos coins. It also tracks the total amount of the coins that are inserted into the machine, and then it sends a signal, or it stores the data for the inserted coins if it meets the vend function, where the amount of coins inserted is enough to vend out the specified product in the vending machine. The machine accepts coin inputs 5, 10, and 20 and output signals for vending and displaying the total on a segment display and a 7 segment display. So in this simulation, I implemented a two 7 segment displays to represent the total amount of the coins inserted in the vending machine. So the one segment 7 segment display is for the tens, and the other one is for the ones digit. So next, for the coin insertion logic, the code tracks inserted coins and updates the total value accordingly. And for the vending condition, the machine checks if the total amount meets or exceeds the product price and sets the vend signal when it's ready to dispense. So here is my Verilog code for the project. So first, we define a module, and under this module, we declared the inputs and outputs. So first, we declared the CLK, or for the clock. This one is necessary to it checks the inputs at regular intervals. So during these intervals, we can ensure that the operations in the machine are synchronized and it updates properly. For the another one is reset. So this input is just like a button that resets everything, the total amount of the inserted coin and the vend variable. So also another input is the 5, 10, and 20 coins. So assuming that we are using a sensor for each coin that is fully functional, that it can detect 5, 10, and 20. So if it detects a 5 pesos coin, then it will be flagged as a 5 pesos coin, and so on and so forth. For the output, we declared vend. This is the output that signals when the machine is ready to dispense the product, if the inserted money is already enough. So another one is the reg 60 for segment 1. So this two is just the 7 segment display representation that I said earlier. Both are representing the tens and the ones digit. So next is for the parameters. For this specific vending machine, I only set one product price, which is 50, and the maximum display that the 7 segment display can output is 999. So for the internal register for total amount, I declared a reg 70 total. This means that I will be using a 8-bit wide implementation for the total amount of money, because 8-bit is equivalent to 255 value at max. So this means that in binary, 1111111, or in short, 8 ones is equivalent to 255. So we're using this to limit the total amount, since the maximum amount that can be displayed in our vending machine is 99 only. The 8-bit reg will be enough to cover up the 99 pesos, because it is up to 255. So for the 7 segment display mapping, we just assign the the map blocks to each of the 7 each of the numbers from 0 to 9 to the 7 segment display. So next, for the main logic, this we use the if block. If the reset is pressed, then it will set the total to 0 and the vend to 0. So the total will be reset to 0, and then the vend will be 0 again. And for the else block, it detects the coin inserted if it is 5, 10, or 20, and it adds up to the total to our input total as to their respective values. And that's how it works in the Verilog code. So for the output, I use the logic for the tens place. I divided the total by 10. So for example, if the total amount is 50, if we divide it by 10, then we will get 5. So 5 will be displayed to the tens place. So for that ones place, to solve this, I use a modulo to check the remainder, specifically modulo 10 to check the remainder. So for example, we have a 57, for example 60, 55, let's use 55. We have a total amount of coins inserted is 55. So if we use the divide by 10, it will be 5. So the tens place will be 5 for the 7 segment display. And for the ones digit, if we use modulo 10 to 55, then we will get 5 for the remainder. So it will display at the ones digit the digit 5. So that way, the 7 segment display can output the correct output that is being updated to the vending machine. That's all for the code. So here is the RTL viewer from the Verilog code, and also this is the successful compilation of the program. That's all, and thank you.